remember to call them explicit, not generic stuff. When you're dealing with recursive, you're looking at how do you write the formula to how the numbers relate to previous terms. That's what a recursive formula is. How do you relate it to the previous term? So if your first term was 5, the next term was 7, the next term was 9, the next term was 11, well, how do you relate the second term to the first? All you do is add 2. Each consecutive term, you're just adding 2 to the previous terms. That's what recursive looks like.
So it's kind of like the rate?
Yeah, and you're going to see really fast here. Once you write out the generic form, the recursive takes 15 seconds to write out. Okay? So let me show you an example here. When we're dealing with the recursive rule, I'm going to look at, we're going to do ones with the arithmetic sequence, and then we're going to do them with geometric sequence. And what we do here is we're always going to write out the explicit rule first. Remember, the explicit rule just stands for the generic formula, okay? The nth term. So I have to write out the indicated rule for an arithmetic sequence. Notice how they told you what it is, which is nice. Your first term is 4, and your difference is 3. So we start by writing out the generic. Your a sub n, your first term plus n minus 1 times your difference. You guys are good at this. Substitution, combine like terms. Okay? Your nth rule, first term, n minus 1 times your difference of 3. Everybody okay with that? Yeah. What do I do now? Distribute and distribute, combine like terms. So your nth rule is, we would say 3n plus 3, or excuse me, plus 1. Is everybody okay with that? So this sequence, we don't have to always write this out. This sequence, if I started to write it out, my first term we already know was 4, the next one was 7, the next one was 10, the next one was 13, and so on and so on. Does everybody agree? Well, like we told us that our first term was 4, the difference each time was 3, so it's going up by 3. So how does 7 relate to 4? How does 10 relate to 7? How does 13 relate to 10? Now, another way of saying this, how does the second term relate to the first term? You add 3. The third term to the second term. The fourth term to the third term. How does it relate to the second term? It's 3 more.
Oh, okay.
How does it relate? So going from the okay. Now the recursive looks like this. The recursive rule, you need to know, you have to always write out 2 things. When you're working with the recursive, when they ask you to write out this formula, you always start by writing out, well, a sub n and a sub 1. Recursive rules have to know where they start from. Because if I just say add 3 to the previous term, well, we can start at 2 and go to 5, 8, 11, and so on. I can start at 0, 0, 3, 6, 9, 12, and so on. I don't know where to start that formula. But if I tell you to start at 4, and then each other term is 3 more than that, we know it's 4, 7, 10, 13. Does that make sense? So that means that I always label out what my first term is of the sequence, which you know how to find a bunch of different ways. And then the recursive part is easy. Each each term of the sequence in relation to the previous term, all you have to do is add 3. So this will equal the previous term. The second term is the first term plus how much? There's your recursive rule. That's it. Think of it this way. The second term in the sequence, a sub 2, is what? 7. 7 is the first term, a sub 2 minus 1, first term, 4, plus 3. The third term in the sequence, 10, is the second term plus 3. That's how recursive works. That's all it is. The fifth term would be the fourth term plus 3. Yeah. All this is, it works out. Yes, ma'am.
So basically, is that the difference?
Yes.
Okay.
Always. Always. It's always the difference. No matter what. The recursive rule always has this in it, and this is always whatever your difference is. Always.
All right.
So this is just for arithmetic.
This is just for arithmetic, yes. The geometric looks just slightly different. Slightly different. And then you always, always, always tell where to start. Yeah.
So, what again is the a sub n minus 1? What is it each part stand for?
What I want you to think of is, this is the first term, second term, third term, fourth term. You okay with that? What I'm saying here is the second term in the sequence is the first term plus 3. So 7 is 4 plus 3. That's what that stands for. How do you get the third term? Well, I take the second term and I add 3. How do I get the fourth term? Take the third term and I add 3. How do I get the fifth term? I take the fourth term. Sixth term, I take the fifth term and I add 3. And so on. It's working its way backwards through it. It's looping itself, like cursive. I just made that up. Makes sense. Okay. Oh, it could be. Yes, it is how they came up with the rule. Okay. Let's try another one.
Okay.
This is the same idea. I'm not going to worry about finding this part for right now.
Don't find A.
Okay. I have two terms in the arithmetic sequence. When you have two terms in arithmetic sequence and you got to write out the nth rule, how do you do that?
Oh,
So-
this is A.
You write it twice, don't you?
Yeah.
Very simple system. Okay. In this case, you'll see it's a very easy system. I'm going to kind of shortcut it through because we're a little short here. I know that my nth rule is first term, n minus 1 times d, and I'm going to do that twice. Okay? So the 13th term is the first term times my difference, and the 38th term is also the first term minus 1 times my difference. Remember that from a couple of days ago? We set it up as two equations. We eliminated the first term, solve for your difference. These numbers work out really clean. We have 1181 is your first term. I'll put this one below here. Plus 12d. 3681 is your first term plus 37d. I just quickly wrote it where I knew what was going to happen because I know that 37 is bigger than 12. Can I eliminate the first term here? Just by subtraction? What's your difference? 100, right?
How is it that perfect? Like just 100 out of all those weird numbers.
It happens. Okay? And then I can substitute this back here to figure out the first term. Bless you, do you agree it's going to be first term plus 1200 is 1181?
Yeah.
So I just subtract it out and you get for your first term negative 19. Okay. So we know that our first term is negative 19. Our difference is 100. The generic or explicit rule then, put it together. First term, simplify out, and there's my generic rule, my explicit rule. When I go to do the recursive then, all I need to write out is what's the first term and what's the difference.
Where'd you get the negative 19 from? Again, I thought you
I substituted in here.
Yeah, negative 119.
Yeah, I wrote negative 119, right? So your recursive then, I should write that in cursive. No, I won't. Thank you. Remember we read it down twice, a sub n and your first term. This will always be first term, or n minus 1. And what was your difference? That's correct. And what's your first term? And all the recursive formula stands for is each term in succession is created by doing something to the previous term. So each term in that sequence, starting at negative 19 to get the next one, just add 100. What do you got?
So you have to write that A sub n.
Yes. If you don't write this part here, you don't know where to start. That's the one weird thing about this. And then when you go from this to the geometric, here what was changing all the time was your difference. What changes in geometric? Your rate. So it's just as easy. When you go with the geometric version of this,
Don't you have to need the cursive form?
I have no idea.
Dude, you don't know math. Okay?
It's just another way of representing the data. When you start out with geometric, we start by just substituting it again. We know what the first term is, we know what the rate is. Okay, bless you. There's my explicit rule. Yeah, that's fine. The recursive rule, we follow the same step. We still got to write down what our first term is and what when we start out with a sub n. So the recursive here with geometric, same thing, a sub 1, a sub n. What did we put after this a sub n in arithmetic? We do the exact same thing, and now what do I multiply it by? R.
Wait, is it n minus 1?
Yep, because it's talking about the term before it. We did the exact same thing in arithmetic, the n minus 1, the term before. The second term is taking the first term, multiplying it by 0.1. The third term is taking the second term, multiplying it by 0.1. The fourth term is taking the third term, multiplying it by 0.1, and so on and so forth. That's all that stands for. But what was your first term? 3. So your first term is 3 or the second term is taking the first term, multiplying it by 1, and going on and on and on.
Of the arithmetic we add.
Correct. Now, your book will sometimes put it backwards. The book sometimes puts the rate, did you get the door real fast? In front of the a to the n minus 1. I'm fine with you putting it on either side. It makes no difference to me. I think since we've been writing it, if you'll get in the habit of putting the the n minus 1 term first is fine. And just throw parentheses around it. So when you're dealing with geometric, it's the same process as working with the arithmetic, or what's called. All you're doing here is figuring out, well, the second term of the sequence is made by multiplying the first term by 0.1. The third term is taking the second term multiplied by 0.1. The fourth term is taking the third term multiplied by 0.1, and so on and so forth. It goes on and on and on. It's, in Clay, you're saying who uses this? You know, stat people, math teachers once a year. It's another way of writing it out. It's another way of how you can write out data sets. It's really all it is. How you can set it, how is the relationship between two values? That's all this we're looking at here, okay? It really is direct substitution. Now, does that mean you're always just gonna be given first term and rate for a geometric? No. That means you could be given 2 terms, okay? If we're given 2 terms, pretty smooth. I try to make you feel good about what you're doing, then I try to whack and just knock all this the humanity out of you. Now, what I want you to do with this one here is I don't want you to write this down. Look at what you have here as far as your terms. Do you have consecutive terms?
Yes.
Yes. That means we should be able to numerically develop the rate. How did you do that? Right. There's science. You blinded me with science.
The negative 16.
Yep. Remember how we developed that before by looking at the sequence? You take the third term divided by the second term, take the second term divided by the first term to tell whether or not it was geometric. In this case, we can tell right away that your rate is -2. Everybody agree with that? Yep. Okay. So if your rate is -2, what's your first term?
-4.
Good. Everybody see that? Yep.
Yeah.
Didn't have to do any work here because it so happened that they were consecutive terms. Thank goodness for that. So my what's that?
You tricked us.
I make you think. I know, I'm a jerk. Now, if you go to your explicit rule, your nth term is your first term times your 8 to the n minus 1. So, nth rule is -4 times -2 to the n minus 1. And recursive is what? All right. Here, and you stay with the doing. I don't do. I've written this like 17 times today. I'm bored. Write the recursive rule. Because if you were a botanist, you might be able to use it. You're not going to be a botanist. If you're a doctor, you can go.
Genius.
Oh, you forgot something. What's the one thing to forget? You have to. That's it. That's it, guys.
Good man.
I'm not using this.
Yes.
No, we have one more.
Get off the stage.
Don't overthink. I'll show you how this works here in 1 second. What I want you guys to do here.
What do you mean?
Yes, ma'am.
Okay, so when you write the recursive, so it's a sub n, and then is it like a little one?
For what? This?
Yeah.
That's all subscript. So I mean, if you want it, that's a to the n minus 1. Sub n minus 1. Now, this is a whole bunch of review junk built into this, and I don't want you to do all of this. What I want you to do is to look at the last, basically, page or so. And I want us to start on 31. We'll talk about the rest of the stuff tomorrow. I want you to work on 31 through 40. It's 10 problems mixed with write the nth rule, and then write recursive.
Alright.
And it's a blended way of doing it, okay? All the answers are on the back. You can check
We
your
just
work.
did this one.
Alright, that's fine.
Wait, so 31 through 40 is the homework?
Here.